Good morning, Algebra 2 and Algebra 2 Concept students. Today's lesson is on 6.6, which is the remainder and factor theorem. So to get started here, we have a function, 3x to the fourth plus 2x to the third minus 5x squared plus x minus 2. Now just a little bit of review. This is a fourth degree polynomial. It's a quartic. The leading coefficient is 3, its constant's -2. The shape of it would be a W shape, it'd be going up. And if we were asked to find f of -2, remember we could do this directly. We could also do this synthetically by putting a -2 out in front, listing my coefficients. And then bringing the 3 down, and then I would multiply and add, multiply and add, multiply and add, and I would get f of -2 to equal 8. All right, now the remainder factor theorem tells me that if there is a remainder of 8, then x plus 2 would not be a factor. It would only be a factor if the remainder would be 0. It would not be a factor because there's a remainder of 8. So we're testing to see if we do f of -2, we are testing to see if x plus 2 is indeed a factor of that polynomial. All right, so the next example here, we've got a cubic polynomial. They're asking us to find f of 4. Again, we could do this directly. If I do it directly, I would basically put 4 in for x. I would encourage you to use the parentheses here. Or you could do this synthetically, so I would put a 4 out in front. I would list those coefficients and then do my synthetic substitution. 4 times 2 is 8. Add those up, that's 9. That's 36, adds up to 31. And then I'd have 124, which gives me a remainder. So f of 4 is 127. That means that x minus 4, again, would not be a factor of this particular polynomial. The next one here, we have a cubic polynomial. Leading coefficient is 1. Constant's 30. Shape of it will be going up. And if I'm going to find f of -3, I could do this synthetically again. List my coefficients. Bring down the 1, do my multiplication. Multiply again and add. And as you can see, I get a remainder of 0. So what that tells me, if f of -3 is 0, that tells me that x plus 3 is a factor of this cubic polynomial. It is a factor. It also tells me that the quotient, if I add my terms here, that x squared minus 7x plus 10 would also be a factor of this cubic polynomial. And by trial and error or by using the method, I could factor this further. I'd have to have x and x. Looking at factors of 10 here, this positive sign tells me that both have to be negative, and 2 and 5 would work. And so therefore, x plus 3 is a factor, as well as x minus 2, and as well as x minus 5. And since x minus 2 is a factor, if I would have found f of 2, that would have been 0. And since x minus 5 is a factor, then f of 5 would also be 0. right, so continuing kind of in that same type of problem, if I'm given a polynomial and they tell me one of its factors, and I'm asked to find the remaining factors. So for this first example, I have a cubic polynomial. They're telling me x minus 2 is a factor of this. So what that tells me that if I do f of 2, and I do this synthetically, this should give me a remainder of 0. Which, as you can see, it does. And this leaves me with the quadratic x squared plus 3x minus 4, which could be factored. Again, I'd have x and x. I have factors of negative 4 would be 4 and 1. I'd want this to be positive and this to be negative. So my outside and inside terms, remember, are giving me 3x. So therefore, these would be the remaining factors. Here's another example. I have a cubic polynomial. They're telling me x plus 2 is a factor. That means that if I do synthetic substitution with negative 2, and this again, be alert here because we're missing the quadratic term or the second degree term. So I need to list a 0 in here. And if what they're telling me is correct, this should give me a remainder of 0, which, as you can see, it does. All right, the remaining factor is x squared minus 2x plus 5. And you can see if I would try to factor this, I would have x and x. Both of my signs need to be negative. And using factors of 5, my only options are 1 and 5. And that's not going to give me a negative 2x, which means this is the remaining factor, but we cannot factor that any further. Now, another example is if you have more than a fourth degree equation, or more than a third degree equation. For example, if I have a fourth degree equation of x to the fourth plus x to the third minus 11x squared minus 9x plus 18. And if they're telling me that x minus 1 is a factor of that. So therefore, I could do this synthetically. I can bring down the 1. And you can see that this does work out. And now I am left with a cubic polynomial as my remaining factor. All right, now previously we learned about if there are 4 or more terms, the only way you can factor this is by grouping. So doing this by grouping, these two terms, I could take an x squared out, which would leave me with x plus 2. Therefore, these two terms, I can take out an x plus 2, which would leave me with a negative 9. And therefore, I've got x plus 2 times x squared minus 9. And hopefully you realize or see that x squared minus 9 is difference of squares, and I could factor that further to be x minus 3 and x plus 3. And so these would be the remaining factors as well as the x minus 1. So I hope this helps you in completing the 6.6 practice assignment.